So what's up, guys? Sounds like it's time to start. So welcome to my talk. My name is Grygoriy, and the goal of this talk is to present my experiences how to deal with this topic. Data consistency in microservices architecture. But why should you care? Because if you lose consistency, you might lose money. Or your customers might lose money, or your company might lose money. Consistency is quite a topic. But first of all, a few words about my experiences and why this topic matters to me. So I'm currently working as a software architect at eBay Classifieds Group, precisely in the motors vertical, which is supposed to help our horizontal brands, such as, for instance, eBay Kleinanzeigen or Canadian one Kijiji, to build cart search experience. What could happen with data consistency at such a domain? For instance, you are going to sell your car, you're going to buy your car, you post an advertisement, and suddenly we lose it. Because we didn't save it properly, we lose the consistency. As a customer, you realize it only in 1 week, and you are a pretty angry customer, so you lose your customer, you lose your money. Before joining eBay, I was working for some time in Hamburg, in 2 fintech companies. The previous was named Creditech. It's a fintech loan credit scoring company. And imagine being a loan customer. So you take a loan, you're the good person, you're repaying your loan. But once we might potentially, as a distributed system, not as a Creditech, lose your incoming payment. And accidentally you will go into collection process. And this is not something you want to have as a good developer and as a good company. The other company is Capital Auto Group. It's a payment system. So imagine you get your salary, and we lose your transaction. So you don't get your salary. Of course, you will call customer support, we will find the reason, we will find it and give it back to you. But as a customer, you won't be happy. So basically, the last 5 years, I'm dealing with microservices or distributed architectures, and during all the time, consistency was quite a topic. How is it specific to microservices? So we design the system as a set of isolated services with different technologies responsible for different domains, with different databases, and as a result, with isolated data storages. So what could happen? We have 2 atomic data stores. We post something. We store it in one, then we crash in the middle. We don't store it to the other. This is exactly how we can lose payments. This is how we can lose listing, and pretty much all other data. So just to recap, the goal of this talk is to present roughly 5 patterns how to avoid such an issues. From more complex to less complex, you will see them all. Small example. Oops. Imagine an e-commerce system. So you are a customer who takes an order. First step, order servers receive your request. We create some initial record like order received. Then we want to charge you for an order. And for that, we call payment service. We did it successfully, but then we crashed, and the order wasn't confirmed. If we leave it like this, we will basically get an inconsistent order, which was paid, but it's not tracked as paid by our order service, so delivery won't be notified. Customer probably will not receive his item. Solution. The most well-known solution to data consistency in microservices, saga pattern. How many of you guys know it? Quite a lot. That's a good indicator, but luckily I have some more to share if you know this pattern. So saga. It has 2 ingredients. The first one is make compensating operations. So assume those are RESTful APIs of our services. We have one endpoint to create an order, we have an endpoint to get order details, and we add in addition compensating operation to cancel an order. So if something goes wrong, we might want to cancel an order. The same with payments. We create an opportunity to create a payment, get payment details, and also cancel payment if something goes wrong. Second ingredient. The step I personally like to name reconciliation. And this fancy name comes from finance industry where I spent quite some time. So if you ever worked with protocols like international transfer, in general interbank transfer, in general banking area, with something like SEPA, SWIFT, you might have heard this term, especially in accounting. So what's reconciliation concept in accounting is about? So it's about taking one account balance, taking other account balance, and see if they match. In principle, this technique can be applied to microservices as well. So we take one service, we check its account, we take another microservice, we check its account. If it's matched, all good. If it doesn't, we apply the previous one, compensating operations. How we can apply this compensating operation and how we can actually figure out, okay, now it's time to check the balances. In general, two options are possible. One is that is frequently applied in accounting and finance industry is on a scheduled basis, try to reconcile your accounting records. So there could be an end-of-day procedure where you run through all your records and you find if they are all consistent one against the other. But this might be not optimal for a customer perspective because if you've got a failure, then we can wait for some period until batch execution will take place. The other one is do it event-based. So back to the example. We created an order record. We created a payment. Now we want to confirm an order. And we fail here. How we can build our business logic? For instance, we detect the failure. We can make a retry by transaction ID. We can load again the status of the order. Or we can redirect customer to the order page, to the list of all the orders. This can trigger basically the reconciliation procedure for this customer. So first step, we look at the customer's order state. And we might detect that there is an order which is in progress state for quite some time. What we do next, we check the payment status of this order. So if this order is paid successfully or not. And the last one, if it was paid successfully, we say, okay, let's move status to confirmed. If item is still on stock, if we can still deliver it, why not? Or if payment was failed, which can be also the case, we need to cancel an order. And this is where this compensating operation applies. So that's the basic example how you can apply saga pattern. So to me, like there are many definitions how to define saga pattern, but yeah, I define for myself as like combination of reconciliation and compensating operation steps. But what if we have much more services? For instance, we order not a shoes on Zalando like I do, or on eBay, but we order a trip, which consists of hotels, transfers, and flights. Here we have 5 services, and they need to be reconciled. And if we will start calling them all over the place to see what the status of one and another, this can get quickly complex, slow, and this code will not be nice and well maintainable. What can we do? We can apply the other solution, which is called application event log. I'm sure you all guys use logs in your daily life for troubleshooting purposes, for figuring out what's going on in your system. So this solution is quite similar. It's just a log. But more structured, maybe in your database as a table, but you are free to use, for example, your log aggregation solution as well. So basically the idea is, in order not to reconcile 5 services to figure out what's the state of current distributed transaction, is to basically go through event log and see where the step is. And by having the knowledge where the step is, you can plan the further step, compensating operation or continuing to finish the distributed transaction. What are the challenges with this approach in general? So as you see, it sounds a lot like an orchestration and not like a choreography. So you might want to have one service who knows the process end to end, which brings some advantages and disadvantages, but you may also be more distributed. So the idea is to gather the events into one place. So you can do it also in a distributed manner, choreography style. Then each service can check on its own what's the current state, how I can continue the transaction. The other challenge is you still have to deal with periods of inconsistency. So at some point of time, until you finish your transaction or you apply compensating operation, your database will have this intermediate state where it has some record in progress and your application need to know how to ignore it. For instance, if you have some order which is in progress, this should not go yet to delivery because we don't know if it's successful or not. The other one, we have to care a lot. So we have to care about reconciliation, we have to care on the business level, how to trigger intermediate state, we have to know how to apply reconciliation. Question. Why don't we have a standard solution for this? There was one, and there still exists. If you're coming from Java background, you may know GDA specification, two-phase commit protocol, XA protocol. So it's basically the way to standardize how to take two different data sources and let them perform in one transaction. I was using actually this, I guess, 5 years ago still in the setup with private data center and with not so high, huge load. What are the challenges of this protocol? So because we have transaction coordinator and multiple participants, two-phase commit double trip, there are two challenges. One is availability of transaction coordinator. If it's not available, then transaction will get stuck, or the performance stuff, or the network issues. So on high scale, in cloud environment, this not always performs well. And the fundamental idea why this doesn't perform so well, in my point of view, is because two-phase commit is trying to address ACID guarantees, which means that records in two data sources either appear at once or don't appear at all. So they are isolated, atomic, durable, consistent, and behave like one transaction. And in real life, this behavior in two different data sources is extremely hard to emulate. Therefore, I wouldn't expect that there will be, or there is, the very standard solution for microservices which will emulate ACID. Therefore, we have to select the other guarantee, which is called base. It's actually a nice abbreviation in front of ACID, but the main idea of base is that you should accept that your data might be for quite some time in the intermediate state. So you might have those records which are in progress, which are not what your business wants, but this is what you need for technical reasons for your system to function. And because your application needs to know how to deal with that, the solution will be always on application side, and I doubt that there could be a magical one which will guarantee consistency between two services without it. Does it make sense? That was the toughest explanation from my talk. All right. Regarding my experience, I have seen Saga patterns actually reconciling like 20 atomic calls with this application event log table. So the process could be like the creation of the customer with many financial accounts. You make many calls so that customer got all the accounts created. So basically this application approach, application log approach, together with reconciliation and Saga can scale pretty well. But it's still complex. How we can make it simple? So what's the key challenge why we need to apply all this stuff like reconciliation and compensation and thinking about two data sources? I guess it's mainly because we are trying to change two data sources at the same time. What could we do instead? We can actually try to change just one. And the other pattern I would present is called change data capture. So what change data capture is about? The same example, order service and payment service. So instead of trying to make order call and payment call in the same process, in the same business operation, we can split those. So first, order service receives the call. Next step, we create a record in database. Order received. Then the separate process can detect this, from the table, or in the other way I will present right now, and actually make a call to payments. So what's the difference? So here, if we fail, the single source of truth will be our database of an order service. Either it all stays, or it's all wasn't saved. So there could not be the case that order service was saved, but payment will never be saved. Eventually, this capture process will take the change and will apply it to payment system. So how to apply this in practice? We could use the same simple structure like an event table. So we could create our internal event. And the other process can poll the table, find the event, send a message. This works, but as you might already guess, this doesn't scale. Or it might scale, but you need to find out the way how to distribute work between several workers, so that not one process will poll your table, but multiple. And this might be not good for your database performance and not easy, not so trivial. There might be a better way. But if, for example, you're searching for specific events, like, for example, the specific failure, and you want to react to the specific failure, then this table will still work. You will just have one worker or the pool of workers randomly polling for the specific status. If the status was found, then specific trigger will be done. Actually, the other techniques are our databases. They try to simplify our life here. So many of those support operation log or change log. These logs could be used internally by databases themselves, for instance, to replicate changes from master replica to read replica, or from masters to followers. They are usually well documented, so instead of polling tables, you can apply and follow the change log. But some technologies made even a one step forward and do this job for us. I'm sure many of you have heard about messaging system, message streaming system Kafka, which goes together with Kafka Connect solution and with some connectors like Debezium. So what this solution can do, it can actually watch your change log on its own and create a Kafka event. So this will be not your code, but configurable solution which will watch for changes in your database and will produce some events. What are the trade-offs? If we go with a packaged solution like Kafka Connect, we basically split a bit our business logic, which is good and bad. So previously, with Saga pattern, we had one process where we can follow and say, okay, first I make an order, then I call a payment service. Now we are split it, we just create an order record, and somewhere else you have Kafka Connect running and replicating some data to the topic. Or you can go with your self-implemented solution and watch for these changes yourself, and then you can flexibly group business logic as much as you like so that its business process is still clear to you, but you have other challenges like how to scale, how to distribute the work, how to hook the changes. The other way around. It's called event first. I call it event first. I'm sure you all, maybe not all, how many of you know event-driven architecture? Almost all. That's nice. So this approach is very event-centric, but comes from the other side. Very similar to change data capture, but different. So the first step, when order service receives a request, we create an event in our event stream. We don't make a database record. Then our event stream is a single source of truth. And actually, our order service consumes this event and updates the state of the order, and payment service consumes the same event and updates the state of the payment. Once again, we have single source of truth for data consistency. Either we have event in the stream or we don't have event in the stream. You might also know the CQRS pattern and event sourcing. So it's also slightly similar to this, but I emphasize that we use it for consistency. So we also kind of have this read model and create command, and this event can be treated also like create command, and your database in order service can be treated as a read model. So it's nothing really new. And for those of you who didn't deal with event-driven architecture, the conceptual change that is important is what type of middleware you want to apply. And there are 3 different conceptual types of middleware you might want to have for your events. The one is message brokers, like RabbitMQ, ActiveMQ, ArtemisMQ. It works with queues and topics. It processes messages individual, and you can get out-of-the-box retry pattern. For example, you cannot process the message now, but you can retry it and process later. You can also use dead letter queue if retries didn't help. But what you can do, it's hard to achieve the sequence of processing because you might have multiple concurrent consumers all consuming from one queue. The other conceptually different solution would be event streaming, like Kafka. So here we got a topic, we have consumers assigned to partitions, and what this solution conceptually can guarantee is, for instance, order of processing. It can guarantee way much more, but the conceptual difference for consistency is this order of processing, because for some use cases it might be important. And if you go with message brokers, you might not be able to rely on this order of processing, but you can rely it here. And there are more technologies like event databases, which allow you to be more like a database. Like Kafka streams might allow you to also emulate or use query-like behavior on top of your streams, but even databases are even more designed for that. And actually, this type of architecture is applied a lot across eBay classifieds. So for instance, in our motors vertical, we rely on Kafka as a single source of truth for many events. For example, whenever you post your car to be available for sale, that goes into Kafka topic, and many other services consume from the Kafka topic. But the question, can we make it even more simpler? And I believe we can. And that's the way how to make it even more simple. Don't care about consistency. Sometimes it's possible. Example, where you don't need an accounting proof precision of your data. It's not about orders, it's not about payments, but it's statistical data you will use for your recommender system. For many algorithms, if you lose randomly like 1% of your events, the recommendation would be still relevant and well personalized. But of course, like if you lose more, then this can be an implication. If you are building some statistic reports, few randomly lost events might be not an issue. So there are use cases where actually you don't need to care about consistency. But of course, you need to carefully evaluate the business perspective, if it makes sense from the business side. The other way to make it simpler. The other challenge we have is that we split the process, which from business side is meant to be anatomic, into multiple services. And what we can do, we can actually think about consistency right from very beginning whenever we design our services. There are many ways how we can do our microservice system design. So first thing, we look at domain-driven design, aggregation root, domain boundaries. We try to separate one domain from another to be able to change code independently and to work maybe in an isolated team on those services. Next, we can have a look on technology side. Okay, there is different problem, different solution that fits to this problem. So we can actually say, okay, the two services belong to one domain, but we may want to split it even further to take some technological advantages. The other way around could be security. So we process something like credit cards, and we don't want our system to be whole PCI DSS compliant. We can take the credit card into separate isolated service. The other concern would be data consistency. So whenever we design the service, we should ask ourselves where are the aggregation roots, transaction boundaries, and consistency boundaries. Maybe this would be a reason for several services not to be a separate one. I have some experience designing, like in accounting area, a few services. Basically, the accounting consisting out of 5 to 7 services. And yeah, there were some consistency challenges because of the distributed systems. And what we did, we basically merged them into one. So I have experience getting from microservices to a smaller monolith. Basically, that's it with patterns. So to recap the follow of my thoughts. The first thing, think about consistency. Whenever you design your services, consistency is one indicator which should tell how you may design your system. Then identify which parts of your system can be not bulletproof in sync. This is usually around some statistic data aggregation, maybe some machine learning functions. Then, in my point of view, it's way much easier to deal with single data source and one atomic change than with multiple data sources. This could be an event-first approach, or apply an event-driven architecture and relying on your event stream as a single source of truth. Or the second way could be this change data capture pattern, where you rely on your database as a single source of truth, and you replicate the changes in the topic for other services, or do it without topic and without events. But then if you don't want to go with those solutions, and you still need consistency, and you still want to have multiple services, you would need some mechanism like sagas and compensations. And you can do this still with choreography and orchestration. But that's actually not all the consistency challenges you might face. The other would be ordering of events. The other would be the way how database indexes your changes. So you, for example, may create a record, it's not immediately visible, it's get indexed within a second. And if you don't build your application to properly react on that, you might get into other sort of consistency issues. So the type of consistency challenges I won't cover in this talk is exactly about the databases, applications, and messaging solutions, so that I focus today only on microservice-specific things. But if you want to go deeper, I really love those two books. The one on the left side, Designing Data-Intensive Application, is addressing exactly the challenges of the distributed system databases and the other consistency issues like ordering exactly once processing, guaranteed delivery, indexing of asynchronous indexing, working with different replicas, and all kind of consistency challenges you might get today. And it has a lot of practical examples with how databases are actually implemented from inside and how databases treat consistency problems. So this can give you some inspirations even for your daily life if you are not a database developer. The second book, which is in early publishing, Stina, I believe, it's Microservices Pattern. And in this book, I found that they address a lot of the challenges I presented today. For instance, there is a good description of relying on events as a source of truth. There is a description of applying sagas. Yeah, so this book explains more in depth some of the topics I presented today. So if you would like to go deeper, I would really recommend this one. And that's it from my side for today. Time for questions.
In most of cases, payment providers send us instant payment notifications asynchronously after payment is committed on payment. So we get a notification and we can act on this. Do you model this in your systems? How do you act with this?
Well, basically, in those examples, it was oversimplified, and the assumption was we just do synchronous call, and the emphasis was not on the payment system, but on the storage itself. So with asynchronous callbacks and notification that could depend on your payment provider and their SLA. If they offer the good SLA and near real-time asynchronous notifications, you might went and reply, for example, also depending on which technology you use. If you have mobile apps, like send a push notification. If you are in the web browser, you may use WebSockets, servers, and events.
Hi.
Hey.
Thank you for the talk. Can you tell if you have some experience with those event databases? What kind of them are you using?
To be honest, I have experience with all the solutions except event databases. And Kafka Connect is used by our colleagues at eBay, but not by my vertical. So event databases, the one that I presented is called Get Event Store. One cool feature I read about this solution that, for instance, what messaging solutions cannot you give is whenever you apply the event and you have some optimistic concurrency control like versioning, you cannot check, okay, atomically, like please insert the event, but only if the last version of this event in the topic is 5. But the event databases can, because they work more as databases, they have some operations like, yes, please insert an event, but only if the last version is this. So it simplifies a bit the work around optimistic concurrency and some other features. So my general feeling about the event data stores, it's more appropriate, for example, for secure REST patterns and where you use it as a database, but maybe not as a way to apply it as a messaging solution. So you might want to have more generic messaging solutions like message broker or message streams, and for something like secure REST, you may use event stores. But I'm sure it's still a viable solution for the service-to-service kind of event.
Hi, thank you for your talk. What I was wondering, I used to have restoration methods on my microservices or services, or when I work with payments, then I first reserve the payment and later I capture it. And the same, if you think on your example with the trips, I have multiple microservices, so I'm reserving each one and then I'm going to finalize at the end. So is this a totally different concept I'm using here, or is it just a more detailed way to do it?
Well, I don't feel so. So I don't feel you're describing a totally different solution. So what you're saying that you make several initial records with some initial state in your service, and then you try to confirm them both. So this is very similar to what I presented, I hope. So you can create the initial record in order service. And for simplicity, once again, my payment service was just a synchronous one with the database, or I can make one call there, and then I make the confirmation of an order service. But it's important because you have several services and multiple records to make sure that, for example, you make the deployment, or for other reason your container or application restarts, you basically fail in the middle of the processing, and you may create one record, and somebody needs to do something with this record later on.
Considering the complexity of this domain, can you see a justification for if you don't need any kind of real-time data transfer, if daily, if weekly is okay, and if you're not at sufficient scale that you and you don't expect to be, can you imagine just allowing direct read access to your source of truth database and essentially doing old-fashioned ETL? So you do a nightly read a SQL view from your database, and it says this is how things are in the source of truth database, and you can update from there and reconcile. And because my fear is that when I set off an event stream and let that keep running for the next 2 years, I just don't know if I have consistent data after those 2 years. And if I want to make sure it's consistent, I'm going to need to start again and run a million events or something.
Sure. So, of course, I would always advise for the simplest solution. And if you don't have your messaging middleware and your business process allows you to be in sync once a week or once a day, then of course don't go for messaging solutions. So why? If it's simpler for you, then yes. Regarding the second question of the database, I still see that you can improve. Like, I don't see the real need like exposing your views in database. You may make a thin RESTful APIs and be confident that you are independent of your schema, that nobody is pulling your workers. But maybe, like, of course, it's not the best pattern to use your database directly, but if it happens in one team, you are in control of your database changes, the process on the other side can adopt yes, it still can be a solution to read, for example, from you, and this is slightly better than reading from table directly. And for example, if you go with a SQL database, which most likely is your case because you are talking in terms of tables and views, then you can also like connect to some read replicas and even not to affect your production system. But not for example, if you have a central data team or the other team responsible for data warehousing, I would not probably recommend to expose your views to the data warehousing team directly.
Hi, thanks for the talk. My name is Jens. I'm a professor in database management, actually, and was very interesting listening to your talk because I also teach the internals of a database system, so what the algorithms are used. And so what you're talking about in database research is called distributed transactions, and you mentioned many of those techniques. And one lesson we learned in database research from all of that is you introduce so much complexity that you better have a very good reason for doing something like that. So you said towards the end of the talk that maybe you better try to consolidate your architecture across consistency regions, aggregation boundaries, stuff like that. And I can only emphasize that there are many, many lessons learned from database research where we've seen if there's a way to avoid distributed transactions or stuff you explained, just don't do it. So a good application should use a common database store, and all applications should be coded against that, and then you get all the consistency for free. All the algorithms you explained, they exist in virtually all database management systems. You get them for free. You don't have to think about that. And I think that's a big gain for a developer, not re-implementing all of this stuff.
Yeah, that's true. And you mentioned like you can have one database and multiple applications consuming it. It comes with a price as well. So yes, I'm not so idealistic and holistic about saying microservices only should use independent databases. I still can see a few patterns. And for instance, I even applied once having one database and two microservices just recently. For instance, I have like highly available microservice responsible for listing display. It should be always up and running with minimum millisecond latency. And then I have process which puts records, index, basically read and write. And this indexing part is asynchronous and can be less stable and can be isolated from favor. So I still see some patterns where to share a database, but just to mention for everyone that it will come with a price. But I guess we are totally on the same page that consistency is a challenge, and if you can avoid it, please avoid it.
I'm seeing your point that if it's across organization boundaries, you have to think about that. But within an organization, I would never, ever try to artificially break my architecture into microservices. Just my 2 cents.
Well, organizations can be big and small. So.
Yeah, I know. I worked for them.
Okay, I guess if there are no more questions, then thank you once more.